Hello student, welcome to our physics discussion, that is physics in a smart way. We had in our last discussion, that is energy of a molecule, gas molecule at an absolute temperature T. So thereby we know our idea was F by 2 or our deduction was F by 2 into KT. How the temperature is linked with the so-called energy and all those things. We have skipped that. We have considered the so-called equipartition of energy. So those are Boltzmann's deductions and all those things. We do not want to make further complication in your idea or in your understanding. You have to grow a bit to know all those things. So we had left there that energy of a single molecule, the so-called kinetic energy, energy of motion, energy of rotation, and that energy of motion is in two parts. One is translation and second is rotation, third is vibration. So all the possible type of energy for a single degree of freedom, that is half kT, and for f degree of freedom for a molecule, polyatomic molecule in general, that must be f by 2 into kT. But you know, we are hardly interested in the behavior or the mannerism of a single molecule. We know we are more interested in the behavior of the gas as a whole. So from a molecule, if you go to a mole, so energy of a molecule was F by 2 into kT, Boltzmann's constant K, and energy of a mole of a gas, we know a mole of a gas consists of Avogadro's number of molecules, that is 6.023 into 10 to the power 23. So thereby, when you multiply Avogadro's number with the energy of a single molecule, two quantities to come up. One is Avogadro's number, that is Na. Second is Boltzmann's constant. They are long lost friends. The moment they are multiplied, they create universal gas constant. So that is F by 2 into Na into Kt, that is equal to F by 2 into Rt, where R is universal gas constant in physics. On SI system, that is 8.31 or 8.3. In chemistry, that is nearly 2, but that is in calorie system. You must be very, very careful when converting all those things. But in physics, in SI system, that is 8.31 or 32, whatever you say. So that is energy of a mole of a gas, 1 mole of a gas, that is F by 2 into universal gas constant of temperature. But normally you do not take 1 mole, you may having 1.5 mole, you may be having you may be having 2 mole, you might be having 3 mole, you might be having any number of mole. Thereby, for a gas molecule, which we may having 1 mole, 2 mole, or any number of mole for n mole. So that is F by 2 into we multiply number of moles, because that is the energy of a single molecule. That is F by 2 into RT. For n moles, that is F by 2 10 RT. So that is supposed to be the total energy of a gas, and that total energy is usually branded as internal energy. But one thing is that I have already pointed out that our derivations, our deduction, our thinking, they are based on half-truths. So thereby, to make it legible for you, to make it easy for you, we have made some oversimplifications in that way. So when somebody says that internal energy of a gas or total energy of a gas equal to F by 2 into nRT, we know that's a very big statement. That is very big statement. But technically, from philosophical point of view, that may be slightly wrong. One thing I can point it out, the degree of freedom of a gas, if let us say if you take the temperature from 0 Kelvin to let us say T Kelvin, we know degree of freedom may be changing from many times. As I have told you before, for hydrogen, if it is extremely low temperature, the degree of freedom can be 3. even if it's molecular hydrogen. So thereby, people do not like to take this as this. They do not like to usually physics. They do not like to talk like this, but they say a more proper statement will be, let me clear up some space. More proper statement will be, instead of internal energy, rather say when temperature changes by a small amount, that is change of internal energy. That is change of internal energy. Change of internal energy. Energy, that is more logical. So thereby we know the symbol will be delta U. The temperature changes by delta T, so that is N into degree of freedom by 2, of course, into R into delta T. So this equation, physicists claim, is more logical compared to the so-called equation U equal to degree of freedom by 2 into nRT. But for a beginner, if somebody takes like that, in my opinion, I think you are correct. I think you are correct because at this stage we got no so-called understanding of the fine of the subject, and the gross understanding, if one gets, that is enough. So that was the thing. Next time we'll be going to our specific hits. So next time when we go into the thing, we'll be discussing that.